What is up, everyone? Welcome to today's video, and today we're going to be covering a slightly harder problem than the last video, and that is the longest substring without repeating characters. So, what exactly is it asking? Well, consider you have a string, right? Any string, and you have all these characters, right? And what you have to do is find the longest substring of characters with no repeating characters. So, for example, ABC is a substring of this string, and it has no repeating characters, right? Because ABC are all unique, they're not repeated. But ABCA wouldn't work because there's two occurrences or instances of A, so A is repeated, therefore this won't work. So in this case, the longest substring is actually ABC, or ABC here. So the length, or the answer would be 3 because the length is 3, right? And here, actually, the longest substring is 1 because the longest substring with no repeating character is just one character, which is B, because all the characters in the string are B, right? And similarly here, WKE would be the longest substring because all these characters are not repeated. And even if you pick like KEW, it's still the longest substring possible has a length of 3, right? And it's important to notice that you can't like pick and choose. You can't pick like, a character from here, a character from here. It has to be consecutive characters, which is the definition of a substring. So let's actually visualize this problem further and how we can actually solve this. So let's say you have, this string, AABC. How are we going to solve this problem is using something called a sliding window algorithm, which is a very common algorithm for solving problems like this with substrings and subarrays. And so the concept is you have two pointers, right? So you have a pointer, call it I, the first pointer, and the second pointer, call it J, right? And you're going to be starting at the beginning, right? The first index. What you're going to be doing is you're going to actually, first of all, check, right, if there's repeating characters in the current substring. In this case, obviously, this is the first character, so there's not going to be any repeating characters because it's the only character, right? But what's going to happen is then you're going to incrementally increase J, so you're going to move J to the next character. And now you're going to check, well, does the current substring, which we have, which is A, right, that's the current substring we have, does it include the current character that J is at, which is A? Well, in this case, yeah. A, the substring A, does include the character A. So what you have to do now is actually move the first pointer up. You have to move it up here. And now you're going to restart the process. And now again, you're going to move J to the next the next character, right? You're going to say, well, does the current substring A include the character B? Well, no, it doesn't. So you add B to the substring, and then you increment J, right? You increment J to go on to the next character, which is C. Now, does AB, substring AB, have C? Well, it doesn't. So you add C to it, and now this is your current substring, right? And this is the longest substring you have, right? So the answer in this case, the length of this substring would be equal to J minus I plus 1, right? So the index, which is J, would be 3, the index of I, which would be 1, so 3 minus 1 is 2 plus 1 gives you the length of this substring, right? Simple enough, right? So this is a very basic example of how the sliding algorithm would work, and then we're just going to basically start writing the code for this. So we're going to actually be using a hash map. You can also use a hash set, but a better implementation would be with a hash map, and that's what we're going to be using in this example, and I'll show you exactly why and how we're going to be using a hash map. So first of all, let's initialize a few variables. I'm going to call this string length, just so you don't have to keep repeating s.length. And then we're going to have, what else are we going to have? We're going to have the longest string. So this is going to hold the value of the current longest substring, right? So it's going to change as we go throughout the loop. And then the next thing is we're going to have a hash map, right? So a map is going to have a key of type character and a value of type integer. Call this hash map is equal to new hash map. Okay, so now you might ask, well, how are we going to use this hash map? Well, this hash map has a key type of character and a value type of integer. So what we're essentially going to do is we're going to have, so let's take the last example. We're going to loop through, right? So I starts here and J starts here. We're going to loop through, and we're going to increase at each iteration. We're going to actually add the current character as the key of the element in the hash map, and then we're going to add the value for that element is going to be the value of J plus 1. Well, you might say, why j plus 1? Well, think about it, right? We're going to need to actually move the first pointer if there is a case of repeated characters, right? So in this case, right, there's 2 repeated characters. So at the beginning, we're going to add a to the hash map, and the value of that element is going to be j plus 1, which is going to be 1, right? So once we do that, right, I is going to be here, and then j is going to be here. And then what's going to happen now is going to say, well, does the hash map actually contain the value, an element with the key of a? Well, it does, and I'm going to say, well, give me that value of that element. And the value is going to be the j plus 1, which was actually 1. So what I'm going to do is going to say, okay, use that value and actually move the first pointer to that value, which is going to be j plus 1, which is going to be here, right? Because j was originally 0, so 0 plus 1 gives you 1. So we're essentially using the value of the value stored with the key as the index of where you would actually move the first pointer to, right? So in this case, what we're going to do is we're going to actually start and have a first pointer variable as well, and then we're going to have a for loop. So the for loop is going to actually have the second pointer, because remember we said we're going to actually increment the second pointer throughout the length of the array. So it's not the array, sorry, the string. So it has to be less than string length, and then we're going to increment second pointer plus plus. Right. So now what? Well, first of all, let's just create a variable, call it current character, just so we have easy access to the character at the current index of this string, right? So so the current string, the string, and we get the character at the current index, second pointer. Okay, so now what? Well, now we actually have to check, right? We have to check if the hash map actually contains the key being the current character, right? And if it does, what do we do? Well, we have to move the first pointer, as you saw in the drawing, right? We actually have to move the first pointer. Well, where do we actually move the first pointer? What do we set the value of the first pointer to be? Well, okay, well, you might say, should we just say hashmap.get current character? Because we just said that we would essentially move it to the index after the current character, which is basically what we're storing as the value, right? Well, it might work for this case, but let's actually take an example where you have A, B, oops, this is too far ahead, and then CA, right? Okay, I can't draw. So basically, you would start as, you'd have 2 pointers at A, right? And then what you would do is you would go and move J to B, and then you would move J here, and then you would say, well, does AB include B? Well, it does in this case. So what you're going to do is actually move I to the next one, which is going to be, sorry, you're here, right? Yeah. And then what's going to happen now is you're going to continue as you were. You're going to continue as you were. J is going to go here, and then J is finally going to reach this point. And at this point, what you're going to say is, well, okay, does the hash map actually contain A? Well, it does contain A because we actually put A right here when you're at this point, right? And so the issue with putting hashmap.getCurrentCharacter is what you're going to be saying is saying, well, okay, find the element with the key of A, right, which is the current character in the hash map, which is going to be at index, which is going to be here, and the value of that element is going to be the next index, so it's going to actually be here. This is where the value of the element is going to be index 1. So essentially, if you actually put this in your code, what you're going to be doing in a case like this is you're going to actually have to move I, the first pointer, backwards here. And that's not what we want, because look, there's repeated characters here, and you're basically moving backwards. So that is definitely not what you want. And so what you have to do actually in your code is check. So you have to get the largest value. So either the first pointer, the current first pointer, or the index value of the value of the hash map element with key A, which in this case would be 1. which one of these is bigger, right? So you can easily do something like this. You can do math.max, so find the max of either this or the current value of first pointer. Whichever has a higher index, stick with that, right? Okay, great. So in that case, we have that, and then now what we have to do is we actually have to update the value of the longest string, right? Because the longest string value is going to change. So similarly here, we actually have to use math.max as well, because you can have a case like this. You can have a case where you have, let's just erase this. You can have a case where you have something like A, D, C, B, B, J, right? And in this case, what's going to happen is same thing. You have I and J here, and then I'm just gonna move on. So J is gonna go here, J is gonna go here, J is gonna go here. Once J gets to this point, right? Currently, the longest string substring that we've come across with no repeating characters is A, D, C, B, right? So what's gonna happen is that's going to be the longest string, right? But then what's gonna happen is once we move I to this point, right, and then we move J to this point, right? Once we move J to this point, now the longest string is still 4, but J minus I plus 1, which is going to be this, which is 0, 1, 2, 3, 4, 5. 5 minus 4 gives you what's it called? 1 plus 1 gives you 2. So the length of this is actually 2, right? So we cannot put this in our code. This cannot calculate the length of the longest string. Why? Because you might have a case before where the longest string was greater. So in this case, the longest string was actually 4. So you have to actually find the max between this, which is the current substring that you're actually in and you're actually calculating, versus the longest string from before. So we can do this similarly. We can say, well, find the max of either the longest string from perhaps a previous substring or the current substring, which is actually second pointer minus the first pointer, right, plus 1, right? So this gives us the length of either the longest string from before or the current one, whichever one is bigger. And then finally what we have to do is we actually have to put the current character as a key, and then we put, what did we say the value was? The value was the index plus 1, right? Because that's where the first pointer might have to move to, right? So now we're actually done. We actually should be done now. Now we just return the longest string. So if we actually run through this, and let's just make sure there's no errors. Okay, let's actually submit it just to make sure. There's a lot of... So there you go. It actually works, right? There are no issues. It works. And so let's actually just take a step back and look through what exactly we did. So essentially what we did, right, is we first of all, we created a hash map, right? And the hash map had a key of character and an integer, a value of integer, right? And essentially what we did is we're going to actually loop through, okay, let's erase this. We're going to loop through any substring, right? We're going to loop through any substring, and then at each iteration, right, first of all, we're going to start with the first pointer, second pointer. At each iteration, we're actually going to store the key, and then we're going to store the index of that character plus 1. So in this case, it would be 0 plus 1, which is 1 here, right? And we're doing this because as we move J along, right, as J moves, we might need to move this first pointer, and so we have to look in the hash map for the key of the element that is repeated, and that value will have the location of possibly where the first pointer should move, right? But in some cases, right, like I said, you might not want to move the first pointer just because the first pointer is actually currently at a greater index, so you don't want to go backwards, right? And then what we have to do is we actually calculate the maximum by either comparing it to the last substrings or the current substring you're calculating. Whichever one is higher is the current maximum, and then you basically put the key, like I said, and the the value would be the index plus 1. And that's it. You're done, right? So this basically used the sliding window algorithm to solve this problem. And thanks for watching, guys. This is a pretty good example to understand, because understanding this will allow you to understand other examples and how the sliding window works. Make sure to comment if you have any feedback on how I should explain these better, or next possible Leetcode problems that you want looked at. Thanks for watching, guys. Make sure to like and subscribe, and have a great day.